lesson on reaction rates background. Different reactions proceed at a different rate. Some goes really fast, some goes incredibly slow. Rate is defined as the change in concentration divided by time. Concentration is abbreviated with a square bracket. If you're doing reactants, it's generally considered R, so this is delta, or change, in the concentration of the reactants divided by change in time. Concentration is molar, but they don't use molar concentrations, they use the definition of moles per liter, divided by seconds, so you multiply by 1 over, so you get moles per liter seconds is the unit of rate. If you were to graph concentration versus time, initially you have zero products because it hasn't started, you haven't made anything yet, and you have a high concentration of reactants. As time goes on, the number of reactants decreases rapidly because it has a lot of things available for it to collide with, for it to react with, and eventually it slows down. Initially, the products increase sharply until it slows down and becomes even. This could go all the way down to zero if it's a goes to completion, reaction goes to completion, or it could set up here, and we're going to talk about that later. So this is the products. This is the reactants. Average change of, say, the reactants. You pick a point, connect lines. So it's change in Y or change in X. Why is that? So it's change in concentration minus change in concentration. Concentration minus concentration, or time minus time. That would be the average. You just go from one point to another point, draw a straight line. Instantaneous is a tangent. So if we're going to find out what the instantaneous rate of change right here, you draw a tangent line to it, and then the slope of that tangent line would be that. So it would be the slope of the tangent line at the point in question. So instantaneous, you have one point. Average, you have two different points. The rate changes with time. If you notice, the slope here is steeper, the slope here is almost zero. So as time goes on, the rates change. Usually they slow down on both sides. Let's see, usually by convention, for the reactant to have a positive number, it's a negative slope here, so the rate is defined as the opposite or negative change in concentration of the R or reactants divided by a change in time. The negative puts it in a positive number. We could have kept it as a negative, but by convention they wanted to work with positive numbers. Rate laws. There are two different forms of rate laws. Again, rates can change as concentration decreases. So if you do initial concentrations, you get a jumping off start. One is the slope at the very beginning, where very soon afterwards. If that is the case, you can also do the rate as K, which is the rate constant, times the concentration of R to the N. And N is the order. Commonly, the order is 0, 1, or 2, which means you're going to be taking it to the 0 power, its constant, 1, which is the same, 2, which is squared. It is possible to have fractions or reciprocals, things like that. So, but standard high school, college, first year college courses only use 0, 1, and 2. You don't have to worry about that. But it is possible to have a non-integer value. Both K and N, the constant, which is the sort of the slope thing, and then the N, the order, are found experimentally. There is no way to do these formulas by theory. You have to do them by experiment. There's no theory, there's no equation that you can put things in to come up and figure out what the things will be. You can guess, but you're often wrong. Each reaction, abbreviation for reaction, and each reactant, if you have more than one reactant, and each product, if you want to talk about formation, has their own unique formula. If you have two reactants, and we're just talking about reactants, reactant 1 plus reactant prime, reactant and reactant prime, you can isolate the first one, and you get a rate is equal to the negative change in R divided by delta R, delta T. Or you can also calculate, or by a different type of experiment, come up with K R to the N. If you are looking at R prime, the rate would be the negative delta R prime concentration divided by time, and that would be a different constant, concentration R prime, to M, a different order. So if you have two things reacting together, you have to set up two different experiments in order to calculate it out. The definitions of these we've talked about, now we're going to name them. The rate equals the rate law constant times R to the N is called the differential rate law. Oftentimes just the rate law. This is the one that is used most often. If you have the rate is equal to negative change in concentration of R over change in time, this is the integrated rate law. And yes, if you know calculus, differential and integrated, it's based on calculus, instantaneous change in slope, limits, and all that other good stuff. I'm not going to teach calculus to do this. It helps if you know calculus, because it makes a whole lot of sense. But you can get by without calculus. We can stumble through it and wave our hands around a little bit if you have to. But you don't need to know calculus to do this. It's pretty easy to do without it. That's the end of reaction rate basics.